Question 9 on page 208, patterns and sequences. In an arithmetic sequence, the sixth term is half the fourth term. So we can see here T6 is equal to half of the fourth term, and the third term is equal to 15. So there's a third term equal to 15. We know that the first term is equal to A in our nth term, A plus n minus 1D. A is our first term, n is the number of the term, and D is the difference. So we can write T1, that is A, but T1 is also equal to A plus D. That's T2, should I say. T3 is A plus 2D, T4 is A plus 3D, and T6 is equal to A plus 5D. Okay, which makes sense if you think about the first term being A, then you're going to add on the difference every time to get to the next term. So if T6 is equal to T4 divided by 2, we can replace T6 with A plus 5D, and we can say, well, T4 is equal to A plus 3D, and we divide it by 2. And then we solve that algebraically to give us that A is equal to minus 7D. Okay, so, but also T3 is equal to 15, so we can write that A plus 2D is equal to 15, and then replacing our A is equal to minus 7D into this here. So we replace this into here. Okay, instead of writing A, we're going to write minus 7D, which is what we just did. So we have minus 7D. So minus 7D plus 2D is equal to 15. We get minus D, 5D is equal to 15, and so on, and D is equal to minus 3. And then from that, if D is equal to negative 3, that means A is equal to 21. So to answer the first part of our question, which is find the first term and the common difference, the first term is 21 and the common difference is 3. So please do, when you've answered these type of questions, don't just leave it, the answers randomly spread throughout your work. Take a moment, highlight the section that they're looking for and write down exactly what they're asking for. It makes some sense to do that. Now, how many terms are needed to give a room a sum less than 65? To give us kind of a ballpark of this, give us some idea, I just said, 21, 18, 15, 12, there are 4 terms. When I add them up, I get 66. So that's no good. But I know that 21 plus 18 plus 15, that's less than 65. So 3 terms will give me less than 65. So will 2 terms. 21 plus 18 is less than 65. And so will 21. That's less than 65 as well. So there's a few different terms of S of n that will give us less than 65. But we'll also have all the negative terms, and then they will give you give you an Sn less than 65. For example, if we started off 21 and 18 and 15 and 12 and blah, 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 and then you're going to get minus 3, minus 6 and minus 9, minus 12, minus 18, that'll go on to minus infinity. So obviously there's a huge amount of those also, will also give you less than 65, an infinity of them. Okay, so let's move on to the next page and see what we do next. We use the term, the Sn is equal to n over 2, 2a plus n minus 1d. We know that our difference is equal to minus 3, and we know that a is 21, so we can substitute those into the equation. And that gives us n over 2, 42, blah, 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 n over 2, 45 minus 3n. Okay, now we want to know the number of terms which give us S of n is less than 65. So we can write that n over 2 multiplied by 45 minus 3n, this here, is less than 65. And then we multiply both sides by 2 to get rid of this fraction here. And we're going to get n into 45 minus 3n is less than 130. And then I multiply the n in. I'm going to get 45n minus 3n squared is less than 130. And then bringing it into an n squared n and constant form, I have minus 3n squared plus 45n minus 130 is less than 0. So when is this curve less than 0? That's what we've just worked out. In order for S of n to be less than 65, this quadratic must be less than 0. So we know that a quadratic with minus n squared looks like this. Okay? And these are our roots, if you like, of this equation. And this curve is less than 0 for all values greater than p. So all up here, all the values up there will be they will all have values down here which are less than 0, and all the values from there across, all those values to minus infinity will be less than 0 as well. Okay, but you need to be careful as well, but of course n is a term number and there are no negative term numbers, so we can never get a negative term, say minus 5 or minus 6, because there is no, the first term we get is term 1. So in n is equal to minus 7 or minus 8 is irrelevant when it comes to this. Remember that the mathematics doesn't know that you're dealing with terms. It doesn't know that what you're dealing with. It just gives you a quadratic that you can solve, and then you can interpret that. So I'm going to get the roots of this particular equation. So I have minus b plus or minus the square root of b squared minus 4ac all over 2a gives me this here. And in my answer, I'm going to get, very nice, n is equal to 3.9 and n is equal to 11.09. They're my two different roots. Now I redraw my sketch again properly this time with focusing on n is equal to 3.9 and n is equal to 11.09. So it still goes like this. And I know that any number or any term which is less than 3.9, in other words, the terms 3, 2 and 1, they will have totals S of n which are less than 65, and any term greater than 11.09, in other words 12 or 13 and so on, they will be less than 65 as well. So I just have a little typo to fix here. It's n greater than or equal to 12. So the terms that will satisfy than less than 65, S of n will be for S of n for 1, 2 and 3, or S of 12, 13, S14, S15 and so on. They will all be less than 65. Okay, hope that helped.